Let's start a new section here. So in this section, we're talking about polynomial functions, and polynomials come up a lot in calculus class. As we get through this class, we're going to be looking at a lot of the properties of polynomials, finding slopes at different points, finding where is it concave up, concave down, and polynomials are good examples for just learning how to do this with different functions. And it helps if you know about polynomials as we get into the calculus topics. So we don't need to know everything about polynomials. We're going to be graphing polynomials in this section, and I'm going to be showing you some shortcuts for how to do that quickly. Because as far as the calculus class goes, it's not important most of the time to be able to precisely draw a polynomial, but you want to be able to generally draw a polynomial. So that's kind of what we'll focus on more in this section. So first, let's define a polynomial. So a polynomial function of degree n. N is a non-negative integer. So 0, 1, 2, 3, 4, 5, so on, is defined by this. And so we essentially have a coefficient times x to some exponent where the exponent is a non-negative integer. And we attach c's by addition. We don't have any division. There's not going to be anything down here, nothing like that. And so then all the coefficients are real numbers. The first one, a sub n, is not going to be equal to 0. And this first one is going to be called the leading coefficient. Now, it's not necessarily first as far as reading right to left. It may not be first. It is whatever number is associated with the highest exponent. So you may see 1 minus x squared. That would be a polynomial. And the leading coefficient would be -1 because you have a -1 x squared. 2 is the highest exponent. So the coefficient with that x squared term is going to be the leading coefficient. Looking at the graphs, so the graphs are always going to be smooth curves with different direction. They're changing directions however many times. We'll talk about that. So we have this blue graph here is x cubed. The red graph is x to the 5th. You can see those look very similar. And then you have over here x to the 4th and x to the 6th. Those look very similar. So what makes those look similar? We'll talk about that as we go along. And of course, these also look like x squared. Now, the main thing that changes, I guess, as we look at these, the higher the exponent, the flatter this part gets, and the wider that flat part will be. It's a little hard to tell here, but if you see here, the red part here is a little bit below the blue part, and so it takes it a minute. It takes the red one, x to the 6th, to get above the blue one, but once we hit 1, then the red one gets higher faster, and so that's because of the exponent. But we'll talk more about that as we go along here. Translations and reflections. So we just talked about this in the last section. Same rules apply. So like I said in that last section, it doesn't matter what the function is. The same, if you do the same thing to that function that you do to other functions, it will have the same effect. So in this case, what do we have? We have the reflection over x. So reflect over x-axis. Then we have the -2 here. If you remember that one, that will move. So when you're inside parentheses, so in this case, the -2 is inside the function. So the parent function is x cubed. The x -2 is inside that cube function. And so the x -2 is going to, if you remember from the last section, you had the minus, that's going to move it move it right. So right 2, and then the +3 out here. This one is outside the function, and that is going to go up 3. And so we start with the basic cubic function that looks like that. We can move it right 2, so that would look more like this. And then we're going to reflect it over the x-axis, so that will look like that. and then we're going to move it up 3. And so then that will look like that. So approximately. But that's the idea. So the same rules apply. If you missed that video, that was the last video that I made for section 2.3 if you're in the class. All right, graph f of x equals 64 minus x cubed. And so you can do the same translation here. So what do we have? We have the minus, and if you like, you can write this as negative x to the 6 plus 64. That's obviously the same thing. So what does this minus do, or this minus here? That's going to reflect over x again. Reflect over x. And then this will shift it up 64. Now, what does the basic x to the 6th function look like? Well, we saw that a minute ago, and it looks like x squared, but it's going to have a much flatter bottom and then have steeper sides as we go along. So we're just going to flip this one upside down, and so that would look like this. And then we're going to move it up 64. So 64, I think these are probably 5 each. So we'll put 64 about right there. And so we got 1 here. And so it's going to look something like this. We're not worried about precision on these graphs. As long as you get the basic shape, try to get the y-intercept about where it should be, or at least kind of the point where it's changing. You want that to be pretty accurate. But as far as the rest of it, we're not super concerned about that. Okay, so what else do we have? So graphing a polynomial. So different characteristics of the polynomial that we need to pay attention to in particular. One thing is turning points. So how many places, so where is the graph changing direction? That is very important parts of the graph. So in this case, we have 2 turning points. In this case, we have 2 turning points. In this case, we have 1, 2, 3, 4, 5 turning points. So the more turning points you have, the higher the degree is. And the degree, again, is the highest exponent in your function. Now, we also have 3 real zeros, and real zeros means real numbers. So the real zeros are where you cross the x-axis. So in this case, we have 3. In this case, we only have 1, but it still says degree 3 on each of these. So there are a couple of different ways that you can tell what the degree is based on the graph, and we'll talk about those in a second. Here we have at degree 6, we have 4 real zeros, and then we have 1, 2, 3, 4. We have 5 turning points again. So just paying attention to those things will help you to figure out what type of polynomial you're looking at. So let's write some of these properties down. So the first one, if you have a degree in polynomial, so degree n, you will have at most n minus 1 turning points. You could have less, so it is possible to have fewer than n minus 1. So if you have a degree 3, so in this case, degree 3, that means you're going to have at most 2 turning points, and we do have 2 turning points. In this one, also degree 3, we have 2. This one, degree 6, we also have 5 turning points, so that makes sense. But the basic x cubed graph, for instance, has no real turning point. So by turning point, we mean it goes from increasing to decreasing, or vice versa. So this one, x cubed, is always increasing. It kind of slows down, but it never actually decreases anywhere. And then same thing with x to the 6th. If you just have y equals x to the 6th, this one only has 1 turning point. So even though you could have 5, like you have 5 here, it only has 1. So you cannot necessarily say that count the turning points and then say it's a degree 1 more than that. But you can't have more than that. You cannot have more than n minus 1 turning points. Next thing we need to know is even degrees. if you have an even degree, so 2, 4, 6, so on, those are either going to, now this is concerned with the end, what's called the end behavior. So the end behavior is, we see the arrow. So now once you see the arrow here, it's just going to keep doing that. We're not going to have any more turning points after that. So what's happening once all the turning points are done? Well, with an even degree, and you can see that here, both of these are going in the same direction. So it's an even degree, they're going in the same direction. Odd degree, you notice these are both odd degree, they're going in opposite directions. So even degree, you either have that kind of shape. Now, you don't know, anything could happen in the middle. It could change however many times it needs to. But the ends for sure are going to go in the same direction. So you either have them both going up or both going down. And in odd degree, they are either going to be they're going to be going in opposite directions. So you could either have this or you could have this. Now, how does that, how do you decide which way it is? Well, that is where the leading coefficient comes in. So the lead coefficient positive, you either have this, if it's even degree, they'll both be going up, or you have this. Now, how do you remember if it's this one or this one for the odd degree? Because obviously with the even degree, it's pretty easy to remember. Positive goes up, negative goes down. That makes sense. But how do you remember when one is going up and one is going down? Well, the way I remember it is if you connect these 2 points, the slope between those 2 points is positive. So if the lead coefficient is positive, the slope between the ends, which there is no end technically, but as far as the graph, you could connect the end points, and that's a positive leading coefficient. This one would be a negative leading coefficient. This one would be a positive leading coefficient because they're both going up. So lead coefficient positive, even degree, they're both going up. Odd degree, it's going up to the right. And then leading coefficient negative, even degree is going down on both sides. Odd degree is going down as we move left to right. So very important to remember, is because later on we're going to be sketching graphs and not just basic graphs like this. Pretty complex graphs, especially compared to what you've probably done in other classes. So you want to make sure you know these things. That will help you. And on the homework, even for this section, the homework is multiple choice. So knowing these things, and I have the next couple examples down here, we'll see this, where you have a polynomial and how can you graph it, and you want to make sure that you're doing this because you're not allowed a graphing calculator on the test. So make sure you can do this without a graphing calculator for when you see one come up on the test. All right, so example 3, identify the degree of the polynomial. Now this should say minimum degree because, again, it's at most n minus 1 turning points. So we're going to count the turning points. So 1, 2, 3. So turning points equals 3. So the degree is at least 4. And obviously even. So it's 4, 6, 8, but probably 4. We can say 4. This one, 1 turning point, 2, 3, 4, and you see the end behavior is going in opposite directions. So turning points equals 4. So minimum degree equals 5. And we could also, on this one, say the lead coefficient is positive because both are going up. And we could say the lead coefficient here is negative because we're going up to the left and down to the right. And that tells you that it's negative. So be really familiar with this. This will save you some time. This is more later on. We can use this kind of as a shortcut to help us. All right, so let's look at this example. So I copied this one directly from your homework. So these are nice. Took a little screenshot from the answer choices you see on the homework. So how can we figure out which one of these it is? And if you see one like this on the test, it'll be multiple choice again. I'm not going to have you we're not at the point yet where we can really sketch these super efficiently, but we will get there. So for now, we're just going to utilize the multiple choice as best we can. So we see the degree is odd. It is 3. So we'll say, well, degree is 3. So 2 turning points or less. We see the lead coefficient is negative. Now, 2 turning points, so we can eliminate that one. This one, 1, 2, 3 turning points. We can eliminate that one. We can also eliminate this one because this one is an even degree, so that is not possible. So that leaves us with either this one or this one, and neither these don't have any turning points, so that doesn't help us anyway. But that's okay. It's 2 or less turning points. So what's the other bit of information? We have leading coefficient is negative, and so that one is negative. This one is positive, so that tells us that this is the correct answer. And so that's the way you should do this. Obviously, on the homework, you can graph it on a calculator, but that will not help you on the test. And so you want to make sure you can do this on the test, and you can do these pretty quickly. If you practice these, I think you can get pretty quick at doing these. Probably even quicker. I think I could do this quicker than you could put it in the calculator and figure it out. So, so practice these, and this is all the information you probably need. And, you should be good. All right, so next one. So we have a 4th degree. So that means 3 turning points or less. You can write or less here. And same thing here. I just didn't write it, but or less. And then leading coefficient, again, is negative. So degree 4, negative leading coefficient. So it's going to look something like this or something like that. And so what do we have? So this one, obviously not. We're going up on both ends. So leading coefficient on this one is positive. This one is an odd degree, so that's no good. So we're going opposite directions, so that tells us that's an odd degree, but we have an even degree here. This one, this is going to be it. So we have 1 turning point, so that's less than 3 that we are allowed. Both ends are going are both going down. And then if we look at this one, just to be sure, this one has a leading coefficient greater than 0 again, so it can't be that. So we have, in this case, we have C. All right, so that's kind of where I want you to be with these. Be able to look at the series of graphs. So you're not going to have to graph these by hand, so we don't have to worry too much about how would we do that. So just be comfortable with looking at these 2 characteristics. That's really all you need for the answer choices that they give you, and you should be able to get it. All right, so next part, we're starting rational functions. We'll do that in the next video, so we'll see you then.